Welcome back. In our fifth installment of this Regents Review series, we're going to be talking everything matter. What it is, how to separate it, how to break down the components of it, what it means. We will also talk a little bit about hydrates and significant figures. And let's go. As usual, these videos are designed to cover the main topics and the main concepts. It won't cover everything. We just don't have time. So, matter can be separated into two major categories, if you recall. We could separate them into pure substances, or we could separate them into mixtures. These are the two main breakdowns of anything that is composed of matter. And maybe we should just go back again. Not that you're going to need this, but let me remind you. Matter is anything that has mass and has volume. Okay, that's what matter is. So we can break down our pure substances into pure substances, right? Can be broken down into two further categories. The main concept, though, of a pure substance is that it is made up of one thing, one type of thing. All right? And because it is made up of one type of thing, you will not be able to physically separate it. So the two types of pure substances that exist are elements and compounds. These two things are made up of purely one thing in terms of matter. So elements could be examples of sodium, oxygen gas, even neon gas, right? Anything that is one element can be shown as a pure substance. And you can't break them down into anything simpler. A compound, you can decompose chemically, right? So we could split apart a compound. And a compound is just when you take different atoms and chemically put them together. Right? Magnesium oxide, H2O, these are examples of compounds. But the thing is, each one of these as an individual substance of matter is a pure substance because it's the only thing in that sample. Mixtures, just like pure substances, mixtures can be broken down into two different types of mixture as well. So they can be called heterogeneous, or homogeneous. Right? And the difference between them is what they look like. A heterogeneous mixture, it looks different. Right? You can see the different things that make up this mixture, like salt and rocks. You can actually see the rock in the salt. Or even salt water and rock is a heterogeneous mixture. You can see the salt water and you can see the rock. But a homogeneous mixture is something like just the salt water. Right? And that's homogeneous because it looks uniform. It looks like it is only composed of one thing. And because these pieces of a mixture have not actually chemically bonded, we can separate them physically. They can be separated physically. And two of the main ways that New York State and the Regents kind of go about this is talking distillation. Right? And distillation is when we separate separating two liquids. Okay? When you separate liquids, you do it by their boiling points. I don't know why. Right? So water and ethanol, they have two different boiling points. If we bring the temperature high enough, the ethanol will evaporate, but the water won't. And that's called distillation. It's a mixture. They haven't chemically combined, so we can use their physical properties to separate them. The other way is evaporation. Evaporation is when we're separating a liquid and a dissolved solid. So you have the salt dissolved in water. Well, all you have to do is boil away the water, and the salt gets left behind. Here's a nice little picture of what we were talking about, right? Matter can be either a pure substance or a mixture. A pure substance can be an element or a compound. Pictures down below. A mixture can be either homogeneous or heterogeneous. And the thing with heterogeneous is you can see the actual delineation between the two different substances that are mixed together. Okay, so that's kind of how we classify matter. We can move on a little bit further, talk a little bit more specifically about some of these things. We were talking about compounds before, and I was explaining how they are chemically combined. They're going to have definite ratios. And because they have definite ratios and they have definite chemical formulas, if we change the ratios, it's going to result in having different physical and chemical properties. Right? So then what makes them up? The best example I have for you is NaCl. Sodium, highly explosive metal. Chlorine, super explosive, super poisonous gas when they are by themselves. But when they are put together in this specific definite ratio, it is something that our body can't live without. Salt. So that's what I mean by when you combine them, their properties change. Mixtures are formed physically, and the components keep their original properties. Original properties. Okay, so when you mix things physically, you can separate them physically. They keep the original properties. You know, before we were explaining how ethanol and water have different boiling points. Well, when you just mix them and they don't actually create a new substance, what we end up with is two different boiling points within the same liquid, and we can use those boiling points to separate them. Okay? So another thing that's common is chemical changes. Chemical changes, physical changes. The most important definition of a chemical change, right, other than how we know it happened, is a new substance is formed. If a chemical change has taken place, a whole new substance has been formed. Now, with that said, we know that a new substance has been formed if gas is being created, if the smell is changing, if we've replaced the color, right? So we've changed the color. If a temperature change has happened. But specifically, this is the one tricky part. Is that not heating something up. Obviously, if I add heat to water, it's going to get hotter. The temperature will change. But I'm adding the heat to the water. When I say temperature change, that would be like the water actually just spontaneously starts to get hot on its own. That would mean a chemical change is happening in that water. Right? And solid formations or precipitates. These are the things that indicate a new substance has been formed. Therefore, these are the things that indicate a chemical change has happened. This picture right here was a nice one that I found. In all of these physical changes, melting of ice, chopping of wood, mixing of marbles, shredding of paper, nothing new is being formed. We're just either changing the size of the particle, or mixing it with another particle, or changing the size of a particle, or changing the phase of a particle, none of which creates something new. But a rotting banana sure does smell funny and sure does change color. Burning of wood smells wonderful, gives off heat, changes the color of the wood. Fireworks, hot, they smell, they have color changes. And mixing of baking soda, gases are formed, temperature changes, and so forth. Okay? So now we'll get to the last part of this topic, and we'll talk about hydrates. Okay? Hydrates are something that have a specific amount of water. It's an ionic salt with a specific amount of water trapped in an ionic crystal. In order for us to do these types of equations, we're going to use percent composition formula. Right? And for a hydrate, you're pretty much always going to be doing H2O over the whole hydrate. And if you don't know what I'm talking about when I'm talking percent composition, what I'm referring to is the formula that is on the back of your reference table that says part over whole times 100. Okay, so you will use percent composition to answer those. And significant figures. There are three rules. Three rules. All 1 through 9 are significant. Any number 1 through 9 is considered a significant figure. When we read a number from left to right, no zero counts. No zero counts until you reach you reach 1 through 9. So what I mean by that is 7. The number 7, one significant figure. 7.3, two significant figures. But if I talk left to right, right, this is what I mean. I reach the number, so I start counting it. Right? Counting this way, I don't even start counting significant figures until I reach a 1 through 9. So no zero counts at the beginning of a number. Leading zeros never count. Decimal point or not, a leading zero never counts until I reach a 1 through 9. And the last part of this is final zeros only count if there is a decimal point. Okay. Final zeros only count if there is a decimal point. And all of these three rules together make sense. So a final zero like this, our rules would say we don't count this first zero. Here we go. And everything after that is significant because there was a decimal point. If I write the number, instead of 0.30, if I just wrote 30, this 3 does count, right? Counting from this way to this way. But the final zero, this one, would not count. A final zero only counts if there is a decimal point. If I change that 30 to a 30.0, well, now all of a sudden, because of this, I can count 1, 2, 3 significant figures. But that changes with that addition of that decimal point. So, thank you for watching this video. I hope this one kind of summed everything up about matter that you needed, and hopefully you can now take this information and go remind yourself what else there is. So thank you so much for watching. Like the video. Catch you in the next video.